So when we add two polynomial expressions, we're going to be adding or subtracting like terms. Now there's two ways we can add and subtract, vertically and horizontally. So when we add two polynomial expressions vertically, how we do this is we write the first one out. And we normally, if there aren't any terms missing, because x cubed, x squared, x constant term, all of our terms are there from biggest degree to smallest. So if we didn't have, say, an x term, we would kind of leave a space there. Because what we're wanting to do is line our like terms up. In our second expression, we have x cubed minus 10x squared plus 8. Now, since there isn't an x term in our second expression, we don't write anything under the x because we're lining up our like terms. We're putting them on top of each other, the two expressions on top of each other. We're writing it vertically. And what we're wanting to do is we're wanting to add these two together. Three x cubed plus x cubed, 1x cubed. 3x cubed plus x cubed is going to be 4x cubed. I have three of them, and I add one more to them, so we should have a total of 4. 2x squared plus negative 10x squared. Negative 2, or 2 plus negative 10. 2 minus 10 is going to be negative 8x squared. Our next one, we have negative x plus, well, we don't have an x term here. We could fill one in if we wanted 0x, because there is no x term in the second expression. So we're really saying negative x plus 0x. Really, we'll just have negative x. And negative 7 plus 8, 3 plus 1. Again, I'm going to show you vertical addition, vertical subtraction, just so we see it, we know what it is, we know how it looks like, or how to do this here. Questions? This isn't normally how we would add two polynomial functions or expressions. The way we will normally add or subtract is going to be vertically, or sorry, horizontally. We're going to add two horizontally. We're going to have them right next to each other. This here is the main way we add or subtract. Most problems are going to be written this way, just like the one we had for the progressive learning question. They're going to put them right next to each other. They're not going to do vertical. And when we add or subtract two polynomial expressions horizontally, the first one, we see if there's anything in front of the parentheses. If there's not a number, not a sign in front of it, we can really just drop them. Notice that we have 9y cubed plus 3y squared minus 2y plus 1. Now, since we're adding, really what we're doing is we're multiplying that second set of parentheses through by positive 1, but it's not changing anything. It's not changing the numbers. It's not changing the signs. So we still have negative 5y squared, positive 1y minus 4. So really at this point, because it's addition, there's a positive 1 in front of the first set of parentheses, so we multiply through by that 1. It just stays 9y cubed plus 3y squared minus 2y plus 1. Since we're adding, we can just drop that second set of parentheses, telling us that we have negative 5y squared plus y minus 4. Now the next step, I'm going to switch colors, because what we can do, and most likely you may or may not do this if it helps, what you can do is go through and group our like terms. So I always start with the y, in this case with the biggest exponent, which would be y to the third. So we have 9y cubed, but I don't have any other cubed terms, y to the third terms, no like terms with it. So I move on to the next one, which is going to be our y squared, because we have positive 3y squared. We do have a like term with it, and it's our negative 5y squared. All I'm doing is putting all the like terms next to each other so that we can combine them. We know what we're combining. Then we're going to go y to our first power. We have negative 2y and positive 1y. And lastly, we have our positive 1 and negative 4 for our constant terms. All I'm doing is putting the like terms next to each other. And especially when we start looking at higher degree polynomial functions, we have these very long expressions and we're needing to combine like terms. You can do this. This does help us make sure that we keep all the terms, we don't lose any terms, we don't misplace anything. You don't necessarily have to do this, but the biggest thing I would say is especially start underlining, denoting the like terms like I did with the different lines, so that we're making sure that all of the terms, all the like terms are accounted for, and we are putting them together. Because what we can say at this point here is 9y cubed is still going to be 9y cubed. There are no other like terms with it. It's staying there. Now our 3y squared minus 5y squared, 3 minus 5 is going to give us negative 2y squared. Negative 2y plus y, negative 2 plus 1 is going to be negative 1y. And lastly, 1 minus 4 is negative 3. So it tells us that our result is 9y cubed minus 2y squared minus y minus 3. That's it. Yes. Questions on this here? Do we like vertical or horizontal better? I mean, they're the same. Vertical is the one we did first, straight up and okay. So we can do this one here. We'll do this one here vertical. The biggest thing I would say is vertical is make sure we are lining our terms up correctly. So with the first one that we have, so add 2x cubed plus x squared minus 3x plus 4. So it's going to go first. 2x cubed plus x squared minus 3x plus 4. So our biggest term is our x cubed term, so we'll need an x cubed, x squared, x constant term. If one of those is missing, you'll need to leave a space for it. Our second expression is x cubed plus 7x squared. Since there is no x term, I'm going to leave it blank. What we could do is whenever we have one of those missing, we can add it in as 0 times that variable's exponent. So here x, because if we didn't have an x squared, we can say plus 0x squared, plus 0x. We're putting in a spot for that term. And the problem told us to add. Whenever I add or subtract vertically, I put that operation between each of the terms just as a reminder what operation we're doing. Since we're adding these two here, we're going to put that spot in between both. Now at this point here, we can add straight down. 2x cubed plus x cubed, 2 plus 1 would be 3x cubed. X squared plus 7x squared, 1 plus 7 is going to be plus 8x squared. Negative 3x plus 0x, negative 3 plus 0 is going to be negative 3x. And lastly, 4 plus negative 2, 4 minus 2, 3 plus 2. So we should get 3x cubed plus 8x squared minus 3x plus 2. Questions on this here? Are you ready for the next one? We're going to do one more with addition, subtraction, horizontally. So the first thing is just writing it. For the most part, especially on the homework, it will have it already written out for us. We don't have to write it out. But as I'm working through and looking at this here, Our first set of parentheses doesn't have anything in front of it besides positive 1, so the sign and the numbers aren't going to change. We can drop those parentheses. Second set of parentheses, all we have is that plus 1, that positive in front of it, so the signs are going to stay the same. We're still going to have positive y squared, we're still going to have negative 6y, and we're still going to have positive 9. Questions on this here? Now we need to combine like terms, yes? Now this one here, I'm going to skip a step. Because if I was looking at this here, the first thing I would do is look at our variable with the biggest exponent, negative 4y cubed. Do we have any other y cubed terms beside that there? No, so that there's, we don't have to combine any like terms with it. It's just going to be negative 4y cubed. It's by itself. And if you notice, I put a line under it because that's the only one that has it, yes? Now our next one would be our square terms. We'll have positive 2y squared and positive 1y squared, yes? Do we have any other square terms? No. So what is 2y squared plus y squared? And it'd be plus 3y squared. But if you notice, I used a different symbol for our y squared and y cubed, yes? It's so that I can visually look and see and check and see, are all those terms accounted for? Because then we go to our single y terms. So we have this one and this one here, negative y minus 6y. Negative 1 minus 6 would be negative 7y. And lastly, 2 plus 9 is plus 11. Now, the way that you denote and put those symbols under there, that's completely up to you. But the reason I do this is especially for when we start getting these massive 6, 7, 8 term expressions that are being added together, I have a visual way to be able to look back and see, did every term, are they accounted for? And are they with their like terms? It's an easy way to look back and see, did I add them right? Are they all accounted for? Did I miss one? I did not, and we can see that the symbols line up, so we know our like terms are put together. Questions on this here? All right, let's look at subtraction. Because I think we feel pretty comfortable with addition, yes? Subtracting two polynomial expressions vertically is going to be almost the exact same as adding vertically, except we're going to be subtracting instead of adding. So we want to subtract 2x cubed plus 6x squared plus 1 from 8x cubed minus 3x squared minus 2x plus 9. So our 2x cubed plus 6x squared minus x plus 1 is going to go on top. And our 8x cubed minus 3x squared minus 2x plus 9 goes on bottom. The one that's listed first goes on top. The one that's listed second goes on bottom. And again, like with addition, we want to make sure our like terms are lined up so that we have our cubics over the top of each other, our squares over the top of each other, x's over the top of each other, constant terms over the top of each other. And for this one here, we're going to subtract. So I would put a subtraction sign between each of these like terms, just as a reminder to myself that we are indeed subtracting. So 2x cubed minus 8x cubed, 2 minus 8 is going to give us negative 6x cubed. 6x squared minus negative 3x squared, 6 minus negative 3. Well, negative and negative makes a plus, telling us that we have 6x squared plus 3x squared. 6 plus 3 gives us 9x squared. Negative x squared minus 2x. Well, the negative minus and negative 2x will make a plus. Telling us we have negative x plus 2x. Negative 1 plus 2 is going to be positive 1. So plus x. And 1 minus 9 is negative 8. Questions on this here? Questions on how we subtracted these two? All right. We'll look at this one here. So this one here, we want to subtract 3z squared plus z minus 4 from 2z squared plus 3z. So if we do this horizontally, we're going to write it out like this here, like we did with addition. All right, guys, focus in. We're going to write it out the same way we did with addition. And just like with addition, our first set of parentheses, we're going to drop those parentheses and not leave anything in front because, again, there's not a number or sign in front of that first set of parentheses. So it's going to stay positive 3z squared plus z minus 4. But since we're subtracting, we have a subtraction sign in front of that second set of parentheses. We have to distribute that negative through. So our positive 2z squared is going to become negative 2z squared. Our positive 3z is going to become negative 3z. Now at this point here, all right guys, let's focus in. We can rewrite this and put our like terms next to each other like we did with the first addition problem. Put our square terms next to each other, our 3z squared minus 2z squared. Then we can put our z terms next to each other, plus z minus 3z. And then lastly, our constant term, negative 4. But since there's not another constant term, it's by itself. Now at this point here, we can combine like terms. 3z squared minus 2z squared. 3 minus 2 is going to be 1z squared, or just z squared. Z minus 3z, 1 minus 3, is going to be negative 2z. And since the negative 4 doesn't have any like terms, it's just going to be negative 4. Telling us that we have z squared minus 2z minus 4. Any questions on how we subtracted these two here? We feel good with those here so far. Now let's look at this one here. We'll subtract these vertically. And again, we got to put the one that's listed first. So our 3x cubed plus 5x squared minus x plus 8 comes first, so it goes on top if we're doing this vertically. Our 5x cubed minus 4x squared minus 3x plus 1 came second, so we're going to put it on. All right, guys, focus in. Focus in up here. The one that comes first is going to go on top. The one that comes second goes on bottom, and we do need to make sure that we line up our like terms. And once we have it written and lined up, it's going to be helpful to put the subtraction between each set of terms just to make sure we are subtracting and not switching from subtraction to addition. Now at this point here, when we subtract 3x cubed minus 5x cubed, 3 minus 5, there's going to be negative 2x cubed. Because when we add or subtract, we're just adding or subtracting the coefficients, not the variables themselves. The variables will stay the same. 5x squared minus negative 4x squared, negative 5 minus negative 4. Well, here our negative and negative make a positive. 5 plus 4 is going to give us 9x squared. Then we can move on to our next one, our negative x minus negative 3x. Negative 1 minus negative 3. Well, the minus negative 3 is going to be the same as plus 3. So negative 1 plus 3 is going to be plus 2. And we still have our x. And lastly, 8 minus 1 is going to be positive 7. Like I said, we have negative 2x cubed plus 9x squared plus 2x plus 7. Questions on this here? We ready for the next one? We want to subtract 5z squared minus z plus 3 from 7z squared minus 4z. So if we do this horizontally, we'd have 5z squared minus z plus 3 minus 7z squared minus 4z. Now for our first expression, we can drop the parentheses because there is no term or expression in front of it. There's no sign in front of it. So the signs in our numbers won't change for this first part here. It'll say 5z squared minus z plus 3. Now our second one will need to distribute the negative through. When we distribute the negative to 7z squared, it's going to become negative 7z squared. We distribute that negative to negative 4z, the negative and negative make a plus 4z. So we have negative 7z squared plus 4z. Questions on how we've done this so far? Questions on any of this so far? Now all we need to do is combine like terms, yes? So if it is helpful to rewrite it like we've been doing with some of these here, put our z squared terms next to each other, our z terms and constant terms, do that. But what's the first thing we're combining? 5z squared minus 7z squared. 5 minus 7 is what? Negative 2z squared. Our next one is going to be our z to the first power, just z. We have negative z plus 4z. Negative 1 plus 4 is positive 3z. And then lastly, we have our constant terms. We have positive 3. Well, that's the only constant term, yes? So it's just plus 3. Negative 2z squared plus 3z plus 3. Yeah. If we did this vertically, we would get the exact same answer, because it'd be 5z squared minus z plus 3. On bottom, we would have 7z squared plus 4z. We wouldn't put anything under the 3 because there is no like term with it. And when we subtract 5z squared minus 7z, 5 minus 7 would be negative 2z. Negative z minus, make sure I put the right sign here, negative 4z. Well, the negative and negative would make a plus. Negative 1 plus 4 plus 3z. Well, there's nothing to subtract from the 3, so it's just going to stay positive 3. So we get the same answer. And realistically, if you're adding or subtracting, how you want to add or subtract, it doesn't make a difference. Whichever way you feel more comfortable with is the way I would suggest doing it. Do we have any other questions on this addition or subtraction? Do we need to see another example of addition or subtraction? Do we feel comfortable with addition and subtraction? Yes. Okay. If we feel comfortable with addition and subtraction, we're going to move to multiplication. So we multiply two polynomial expressions. We're going to write them next to each other inside parentheses, and then we're going to distribute. So we're going to multiply through. So we multiply through, the first thing we're going to distribute is the negative x squared. We're going to multiply it by every term in the next set of parentheses. So negative x squared times x, still going to be negative. X squared times x is going to be x to the third. When we multiply like bases, we add the exponents. So x squared times x is going to be x cubed. Then we're going to do it also negative x squared times negative 3. Well, the negative times a negative give us a plus. X squared times 3 as well. 3x squared. Now we've multiplied through by the x squared, so we'll move on to the 2x. So we're going to do 2x times x. And 2x times x is going to be plus 2x squared. And 2x times negative 3 are 2 times negative 3. Almost. Negative 6, because positive times a negative be a negative. 2 times 3 is 6. Since the 3 doesn't have an x, but the 2 does, we still just have an x. And lastly, 4 times x is going to be plus 4x. And lastly, 4 times negative 3, negative 12. So we distribute through, we multiply each term in the first expression by each term in the second expression. Questions on what we've done so far? And once we finish multiplying through, we're going to combine like terms. X cubed is our biggest term, so we'll start with it here, and negative x cubed has no like term, so it's just negative x cubed. Incidentally, just how this one works out, our x squared terms are already next to each other. 3x squared plus 2x squared would be plus 5x squared. Negative 6x plus 4x, negative 6 plus 4, negative 2x. And our constant term, negative 12, does not have any like terms, so it's just minus 12. Questions on this here? Let's look at another one. We have y plus 5 times 3y squared minus 2y plus 2. So what we want to do first is distribute the y. So y times 3y squared. 3y cubed, because 3 is being multiplied with 1, so we still have 3. Our y times y squared would give us y cubed. Y times negative 2y. Negative 2y squared. And lastly, y times positive 2. 2y, yes. Plus 2y. Now we're going to do the same thing with positive 5. 5 times 3y squared, 5 times 3y would be 15y squared. 5 times 3 is going to be 15. We still have our y squared term. 5 times negative 2y, 5 times negative 2, negative 10, and we still have the y. And lastly, 5 times 2 is going to be plus 10. Bless you. Now at this point here, we can combine like terms. 3y cubed doesn't have any like terms. Our squared terms, we have negative 2y squared plus 15y squared. Negative 2 plus 15 is going to be plus 13y squared. 2y minus 10y is going to be negative 8y. And our constant term does not have any like terms, so it's just going to stay plus 10. Telling us that when we multiply these two together, we get 3y cubed plus 13y squared minus 8y plus 10. So, questions on how we multiply these together? Do we feel comfortable with multiplication? Yeah. I have a feeling most of this is just a recap of what y'all have done before, yes? Okay. Even with 3 multiplications, we just do 2 and then the third. Do we need to see an example of multiplying 3? No. No. Okay. In that case, you're finished with this here. 4 through 14 even. 18, 19, 21, 25, 27, and 30. Four through 14 even. So you're performing the operations really on all of these here. Thank you. So 4 through 14 even, adding, subtracting, you can add vertically or horizontally. It is up to you. You get to choose which way you do those there. 18, 19, 21, 25, 18, 19, 21. Multiply those two together, simplify. 25, there's an error in what they did. Got to fix it. Explain and fix. 1 and 7 and 30, just multiplying out. Y'all have a good rest of your day.